time back, and now it is functions. I hope you are going to enjoy these functions. They are quite difficult. But I hope that you people who's trying to get a high symbol can do the basic functions. I hope you can all draw a function and derive the equation of a function. In these sums that I'm doing with you, there will be some questions like that, but a lot of these questions are going to be a little bit more difficult. Right, let's have a look at the first question here. Given gx is equal to 4x squared minus 6. People, this is a parabola, you know that. It's a grade 10 parabola. Don't get confused because there's no third term in it. This is a parabola because it's x squared. Then fx is 2 square root x. What is that? It's also a parabola, but it is the inverse of a parabola. The graphs of g and f are sketched. S is an x-intercept. Let's go to the sketch quickly and see what we can see there. Ah, there it is. Right, people, let's see. In this sketch, they said, the graphs of g and f are sketched. S is an x-intercept, there it is, of g. Now, there's your g, okay? You read your questions as well as possible. Look at what they've given. Write in something if you want to write in something. It's always good to have things on your sketch that you can use, okay? Okay, S is an x-intercept of g, then, and k is a point between O and S. The straight line QXT, this one, QKT, is parallel to the y-axis, and T on the graph of G is parallel to the y-axis. This one is parallel to the y-axis. That is T. It intersects the parabola there. This is our fx. Can you see it? It's the inverse graph, and only half an inverse of a parabola that they got from somewhere. Okay. Now the questions, people. They say, determine the x-coordinates of S correct to 2 decimal places. Oh, people, that should be very easy. Because in all the graphs that you've done, there are x-intercepts when you make your y 0. The y-intercept when you make the x 0. All your graphs. So this thing you can't forget. You can't forget that when you do graphs. Okay. Now what are we going to do? We're going to find that x. That's the x-intercept of S. Now S is an x-intercept of which graph? Of gx. There it is. Now let's have a look. The x-intercepts, you make y0. y0 of gx. And in your gx, you make your y0, there it is, and then you solve for x. X squared is 6 divided by 4. So x is going to be plus or minus the square root of 6 over 4. The square root of 6 over 4. And that gives me 1,2247 plus or 1, or negative. But people now, remember the square root is always positive or negative. But if you go to your sketch, S is on the positive side of the x-axis. So S is going to be positive 1,22 if I round it to 2 decimals. Have you got that? That's question 1. Not difficult at all. Next one, you see it's only 2 marks. So you've got to do that very fast. Very, very, very fast. Because people, you can't think too hard for the easier questions. It must come as a natural thing to you. Right, the second question. Write down the coordinates of the turning point of G. Again, so easy, people. 2 marks. This one you can do in 20 seconds. The turning point is always when you make your x 0 because it's on this graph. There's no axis of symmetry except for that, which is x is 0. this axis of symmetry is x is 0. Can you see that? Right. So the y-intercept will be that one, and that means your turning point is 0 and negative 6. Very easy, do it in a very short time. Then 6.3.1. Write down the length of qxt in terms of x, where x is the x-coordinate of k. The x-coordinate of k there, and then it will be the x-coordinate of k there also. Can you see? But we still need the y value there. We only have the x-coordinates in terms of x. So we've got that. Now people, if we want to find the length or the distance between two graphs, we have to get the two graphs in standard form and then subtract the equations from one another. That will give me an equation in terms of x for qkt. So we're going to subtract the two graphs from one another. Because why? Because we need the lengths of this y length, these two y lengths. If we can get y for this one, it's going to be the length of qxt. So it's a vertical distance, it's always the y. Right, let's see. We take the two equations, there's the one, there's the other one. Then we subtract the bottom from the top, and that will give me qxt. Now let's see. qxt. Have you got it? You subtract the bottom graph from the top graph. See what I did? I did put the negative there because it's this one, but it should be subtracted from that one. Okay. Then I rewrote it so that it looks more usable, and I said 2x square root x minus that, and it became minus 4x plus. Oh, people, be careful for a negative in front of a bracket. It always changes the whole sums brackets, signs. Right, now you've got qkt. Wonderful. That is the distance between the two graphs in terms of x. So what do I need? If I could find that x value, I will be able to substitute it in here, and that will give me. Can you see this looks like a parabola, but it's a square there. But it's only the length of that line in terms of x. So don't think this is going to be a parabola, okay? Then the next one, 6.3.2. They said, calculate the maximum length of qt. Oh, now I've got qt in terms of x. Now for a maximum, I hope by now you'll scream it out. To find a maximum, when you do calculus, you take the first derivative equal to 0. Now people, you can also do that method when you have a parabola. First derivative equal to 0 will give me the x value of that qkt. And then if I substitute the x value in there, I will get the length of qkt. Because qkt is a y. You can actually say it's y. Right. Now, there's another method, except from first derivative. You've got a formula. If you've got a quadratic equation, you can also use your formula to find the axis of symmetry. But let's say this is not really a parabola, but it is a quadratic equation. And the formula to find that is x is minus b over 2a. There I wrote it for you so that you can see. For the maximum length, you find that x using the quadratic equation written in the correct order. It's not in the correct order there. And then take that x, substitute it into that one. But look at the other formula, the other method. Maximum, minimum, first derivative equal to 0. You use that right through calculus. Up to volume, you say first derivative equals to 0 for a maximum. Right, so I'm going to do this little method with you. That is your first derivative from there. Because this is 2x to the power half So the derivative will be a half times 2, which is 1 there. And then you subtract 1 from a half, and that gives you negative a half. That one is easy, 8x to the power 1. That is your derivative. Now you take that derivative and put it equal to 0. And people, if you get there, you are going to see that this is not so easy. Because look at all these halves there. But for the bright child, it's not too difficult. You can take out x to the power half as a common factor. It goes into that one once, and into that one, if you divide 8x by x to the minus 8x divided by x to the minus a half. What do you do with your exponents when you divide? Yes, you add them. So this is going to be 1 minus a half. So it's going to be 1 plus. You don't add the exponents, you subtract them, but in the end, you're going to add that half there. Can you see that? 1 minus a half gives you positive a half. So it's 1 plus a half. It's 1 and a half. Can you see that? It's not so easy, nah. I'll show you the other method just now, which is actually a little bit easier in this case, where you have fractions. So now you solve for x. X to the power negative half is 0. There's no solution to that. No solution to that. But this one has got a solution. Now I wonder whether I redid it there. Yes, I did. Because here I had to cram in all the things, and now I can show you very clearly how this is done. Look at this. Let's start there again. The first derivative is equal to 0 for a maximum. The first derivative is that one. I take out the x minus a half as a common factor. I get 1 minus. If you divide the x by x minus a half, it comes to that. And then I solve for x. X to the minus negative a half. No solution, people. No solution. But in this one, you've got 1 minus 8x to the power 3 over 2 is 0. So minus 8x to the power 3 over 2 is negative 1. The negatives will cancel. X is 1 over 8. Is negative 1 over 8, but it's x to the power 3 over 2. Now x to the power 3 over 2, I want only x. So what do? I multiply the exponent by 2 over 3, so that these can cancel out, and I've got x to the power 1. But I do the same on the other side. 1 over 8 is actually 1 over 2 to the power 3. Remember exponents. When you work with exponents, you should always remember prime factors also. Okay? So that is 2 to the power 3. Then I multiply that one with that one, and I will get 1 over 2 squared. Because the 3's will cancel, it's 3 over 1. And I will have 1 over 2 squared. You can write it like that. You can write it like that. It will all give you exactly the same answer, and that is 1 over 4. Have you got that one? Let's go to the other method, because the other method is very useful and very important also. Did I do it? No, I didn't do it. I'll do it with another sum. Okay. That one with x is minus b over 2. Oh, no, here I did it. Ah, wonderful. Okay, there I've got my x a quarter. Then I go maximum length, substitute the x a quarter into the original equation of qxt. That equation, substitute in there, and this is going to give you the length of qkt. And if you substitute correctly, the square root of a quarter is a half, and in the end you are going to get 6 and 3 over 4. Have you got that one? That is using the first derivative. But you can also use the other method. Here it is. Let me show you. The other method is also very possible. There it is. Qxt is that. We know that now by subtracting the equations. I rewrote it in correct order from highest to lowest exponent. Then I say x is minus b is minus 2 over 2a, which is minus 8. And that will give you minus 2 over minus 8, and that is a positive a quarter. And then you do exactly the same that you did there on top, where you found the x using calculus. You take that quarter, substitute into the original formula, and you will also get 6 and 3 over 4. Not difficult, people. This one is still quite an easy sum. I don't think it's close to 11/4 sum. It's actually rather 11/3 sum. But it is quite tricky. The maximum length, remember, it's like working out the maximum of a graph. And that is first derivative equal to 0. Or, with the parabola, you determine the axis of symmetry. When you have the axis of symmetry, substitute into the original equation. That will give you the y value. In other words, the vertical length of that line. Okay, people, I hope you understand that one. Right, let's go to a next one. Question 8. The sketch represents the graph of functions ax squared plus bx plus c and gx. So this is f, and the gx is, what kind of graph is that? Exponential. Oh, people, you must be able to recognize the different graphs. This is an exponential graph that moved up or down, because q can have a positive or a negative value. That is the one that shows us how much the graph went up or down. But we don't have it at the moment, so we'll have to find it. Okay. The x-intercepts, there they gave us that, and I wrote it on the sketch. The y-intercept of f is C06, I wrote it in there also. The graph of g passes through the origin, there it is. So can you see, if it was an exponential graph, normally a normal exponential graph without that q will always pass through 1 there. But now, the graph went down. So before even calculating this, what will the value of q be? It should have been through 1, now it is through 0. So the value of that q is -1. Can you see? It's good to see these things without calculating, because sometimes that is very possible. Okay, the first question. Use the graph to determine the values of x where fx times gx is smaller than 0. Now, fx accent x. Now, f derivative of x. That means I'll have to get the derivative of the parabola, which will be a straight line, and then I'll have to compare it to gx, which is an exponential graph. Now, people, the method that I want you to use is, I'm going to do it at the end of the sum, because I need to find the equation of the parabola first. And then it's really not so difficult. But there's another method there with a gradient, but I don't like that method. So I'm going to do all the other sums, then I will get back to A. Right, let's have a look. B, determine D and Q. Now they want us to determine the D and the Q in our exponential graph. Okay, let's have a look. What points are on the exponential graph? People, you've got to find two derivatives. Two. That means you'll have to get two equations so that you could do a simultaneous equation from that. If you've got to find two derivatives, you do a simultaneous equation. Sometimes it's very easy, sometimes it's not so easy. So let's have a look whether this one is easy or not. So you substitute 0, 0 into gx because it goes through that point. So that point is on the graph. And you will get 0 is equal to d to the power 0 plus q. Now d to the power 0 is 1. So q is 1, negative q is 1. So q is negative 1. Did we say that when we looked at the sketch? Yes, we did. Wonderful, people. There you've got Q. So this simultaneous equation is very easy. You only take the Q and you substitute it back into the equation. So I'm going to substitute the Q into this equation. There I have the Q. There I have a D, which I don't have yet. So what I do now, I take the other point through which this graph goes, and you substitute it into there. Because the other point, a point on a graph is always x and y. X and y. So you're going to substitute 2 into y, and that is your Q. And then for x, you don't have, your x is there. So there you have got the 1 from that point there. Okay, now we can solve D. D is going to be 3, because I take that one to that side. That was quite an easy simultaneous equation. But you should know how to use this. So that makes this sum quite difficult there. How do you feel about it? Difficult. Yes, because how will I know that I must substitute both the points? All I want you to remember is the fact that if you've got 2 variables that you must solve, you normally must have 2 equations. That might help you to remember that you can substitute those 2 points into the equations. People, are you feeling all right about this one? I hope so. Okay, then, determine A, B, D, first for D. State the domain of G negative 1. What does that mean? The inverse of G. Wow, people, the inverse of G. How do you find the inverse of a graph? The inverse of a graph, it's a mirror image in the axis y is equal to x. That's the inverse of a graph. Now we are going to use that graph, but we've got the equation of that graph. We can actually rewrite it now. It's going to be gx is 3 to the power x minus 1. That's going to be the equation of this graph. So if we want to find the inverse, we're going to get a mirror image in the y is x-axis. So x and y swaps places. That's all when you do an inverse. Now let's have a look. Oh, I didn't do the domain. I'll do it now. Let's look at this one. Oh, I skipped C. That's why I didn't get to that equation. Okay, let's go quickly back. Determine the inverse of G in the form y is. Okay, the inverse means x and y swaps. For G, it was y is 3 to the power x. There's the inverse. Then you say, oh goodness, how can I solve for y there? Right, because I want the domain here. So what I'm going to do here, 3 to the power y, I'm taking it to that side, but I'm keeping the sign positive. So I'm actually taking that one over there. It becomes a positive. So 3 to the power y is x plus 1. Now, people, that is the equation, not yet, because they said starting with y. So you can say y is x plus 1 over 3. But, people, do you recognize this? This is an exponential form equation. I can rewrite that in log form. And, oh, people, when you get the inverse of an exponential graph, it must always be a log graph. You cannot solve this y here and say y is x plus 1 over 3. No, no, no. The inverse of an exponential graph is always a log graph. So, I'm going to write this in log form. Log x plus 1 to the base of 3 will be y. Can you all rewrite from exponent to log? This is the base, so it stays the base there. The y will be the left-hand side, and the x plus 1 will be the number at the log. This is the equation of Mr. Inverse from that exponential graph over there. It will go like through the x like this. Okay, thank you. Now we go to D first. State the domain of G's inverse. The domain. That's easy. People, and you don't do this much in class. So, remember the domain of a log graph is always that x larger than 0. Because in logs, the number next to the log may never be 0 or a negative. That means this must be larger than 0. So x must be larger than -1. And that is the domain of this graph. X larger than -1. Right. Have you got that one? Let's go on to the next one. Number E. Now I'm at E. Okay. They say, determine A, B, and C. Now, don't do what a child once did in the exam. He had his hand in the air and he said to me, Miss, where do I get A, B, and C? I don't see it anywhere. So I said, just go back to your question. It actually means you must find the equation of the parabola. There's your ABC in the question. Can you see it? Oh my goodness. You felt very bad because you didn't see that. That's why I say, read this question. Mark something there if you want to mark it, so that you have all your information in your head before you start with the questions. Right, let's go back to number E. Now, people, let's have a look. If you look at number E, determine A, B, and C. To find the equation of a parabola, you need either the turning point and one other point on the graph, or you need the x-intercepts and one other point on the graph. So people, if you look at this parabola, let's go back again. What do you have there? You've got the x-intercept and you've got one other point there, which is actually the y-intercept. So now we decide on the formula that we're going to use to find the equation of this specific parabola. And there it is, people. This is how you're going to find, you are going to use that formula. What formula do you use when you have the turning point and another point? You are going to use fx is a x minus p squared plus q, where p and q is the turning point and x and y will be the other point on the graph. Right, let's have a look. You have the x-intercepts, you have them. And you have another point, the turning point y is 6. Why do I say you have that one? It's not the turning point, people. It is the y-intercept. Can you see that? And therefore, x is 0 over there. Have you got that? Right. So, we've got the x-intercepts, and we've got x is 0, y is 6, x2 is 1, those are your x-intercepts. That's the other point on the graph. Now you substitute. You substitute them all. Sometimes some teachers will say to you, first substitute the x-intercepts, then substitute the other point. I always say, no, write down everything you have. x1 is an x-intercept. x2 is an x-intercept. Those two comes from that point on the graph, the y-intercept. Okay, now you substitute it into that equation. It's so important that you know this equation. Very, very, very. And that's where you start, and I'm glad we could do one of these. Why do I substitute everything? So that I can determine A. X is 0, y is 6. The first turning point is -3, but there's a negative in the formula, so this becomes a positive. There's a negative in the formula, so this one becomes a negative one. That's where you get your x-intercepts from, people. Then you've got 3, negative 3, negative is not very clear, is equal to 6. And then a will be equal to negative 2. Have you got that one? So now you've got a, and now you go back to the formula. You go back to that formula. And now you don't use the other point. You only use the x-intercepts and a. And now substitute a is minus 2, x is negative 3, and x2 is 1 into the equation. And it's going on the next page. I'm going to do this for you so that you can see how it follows one another. So now I'm going to what? I'm going to take those values and I'm going to put it in here. x1, x2, a. The y and the x must stay there because in any equation of any graph, you must have an x and a y. So you only use that other point to find a there. Can you see that? Right. So now we multiply this, remove the brackets, and there's the equation of that graph. But they actually only asked the value of A, B, and C. And that will be A, B, and C. You got that? Okay, people. Right, let's go on. The next question, let's go back to the question first. Before we do it, we must now do F. Draw a sketch graph of F inverse of F. Show the turning point and the intercepts with the axis. So we must take that graph and draw the inverse of that graph. Now I'm going to put the graph here so that you see it while we do the inverse of the graph. Otherwise, it's difficult to do it. Right. There's F. The turning point of F is negative 1. X is negative 1. That is your parabola's turning point. So people, if you get the inverse, what's going to happen? X's and Y's will swap places. Okay? Substitute Y for Y. We've got the turning point negative 1 there. We know that this is negative 1. How do we know that? Look at this. You could just find the axis of symmetry. Because axis of symmetry is minus b over 2a. And there's minus b over 2a. And that gives you negative 1. And then I want that y value also, because I want to know now how I'm going to draw the inverse of this graph. Substitute the x negative 1 into the equation, that's your y. But now people, if you determine the inverse, the turning point of the new graph will be not negative 1, 8, it will be 8, negative 1. The x and the y swaps places. Can you see that? Right, there you have the new turning point of your inverse. The x-intercepts will also swap. So, instead of having 0, 1 and 0, negative 3, you're going to say, no, the x-intercepts was 0, 3 and 0, negative 1. Now I swap them. The one will be positive 1, the other one will be negative 3. So the x-intercepts will be negative 1, positive 1 and negative 3. The old graph, x-intercepts were negative 1 and positive 3. And now we swap them. Because when you do the inverse, we swap the x's and the y's. So there's your new x-intercepts. And this is how you're going to draw the graph. It's going to look like that. The inverse of that graph. People, just imagine the other graph was there. You get a mirror image. Y is x-axis. So it's going to turn and it's going to be there. So there's your inverse of the parabola that we've been working with. Have you got that one? Sorry, I'm not a good writer My left hand is not good. Okay, but that's fine. Let's have a look at the next question. The next question, G, and I want you to see the question. So I'm going to put it there so that you can see it. The question says, determine the values of k for which fx plus k equals gx has two roots that are opposite in sign. Wow, these are the questions that most of you just ignore. But let's see whether you might be able to understand it today, and then you can use it. You can use it in the final exam or in this June exam. Now, good. They said, find the values of x. Find the values of x, okay, k in this case, for which fx plus k is equal to gx. Now, fx plus k, there's your fx. There's the formula of fx. Can you see that? Because it is your, sorry. There's the formula. Fx plus k, this is what you've got. It was given to you. And now they say, calculate k if two roots with opposite signs. Right, let's have a look. Right, this is going to be fx plus k. And that should be equal to gx. Now, people, what are we going to do to find k? The only thing that we can do, we must make x 0, because k has to do with the y-intercept of your graph. Can you see that? In a parabola, this constant number at the end is always your y-intercept. So we're going to make x 0 in both of the graphs. Now, if we go to the G graph, if you make x 0, you've got 3 to the power 0, which is 1, minus 1. And that gives you 0. So there I'm going to have 0. If I make x 0 here, both these terms will be gone. So I'm going to have 6 plus k is equal to 0. So k is equal to negative 6. But, people, I want you now to look at the graph, because there's something that you've got to realize. Let's go to the graph with that answer that we got there. People, k is part of our y-intercept. We said k influences the y-intercept. So if k is equal to 6, it means this parabola is going to move downwards by 6 units. It's going to cut through the origin. So how many roots will that parabola have? It will have 2 roots, but the 2 roots are not going to be opposite in sign. Can you see that? Because I'm going to draw it now that you can see it clearly, but it can be confusing with the first questions. Look at this. I'm going to draw a little parabola here, because that's what's going to happen now. Can you see that? The parabola moves down, and it's going to cut there at 0. And they said, you must determine a value for k, which will still give you 2 different roots, opposite signs. Now, if you move 6 down, you're not going to get 2 roots with opposite signs. You're going to get 0 and 1 negative sign. So you want a positive sign. So you'll have to take this graph upwards a little bit. Can you see that? Because then you've got a positive root and a negative root. Difficult, ne? Okay, in the old days, you left this out, but you're not going to leave it out now. You're going to get your k, then you're going to go back to the graph to see whether that k will fit the restriction. The restriction said the 2 roots of the new graph must still have a positive and a negative root. Right, people? So, k cannot be equal to negative 6, but k can be smaller or larger? If I make k 5.5, what did I do to the k? I said negative 6. Now I say negative 5.5. The k became bigger. Negative 5.5 is bigger than negative 6. So we will have to say k must be larger than negative 6. If it's 5.5, the graph will go down 5.5 units. It will go through there, where that second little graph, and it will give us a positive and a negative root. Wow, quite difficult. Nee, right, people? But if you listen to it again and again, I hope you will understand. This graph moved downwards. You can see that, negative 6. If you go back to your graph there, and you put a negative 6 into k, what is the y-intercept going to become? 0. It's going to go through 0, as I've shown you. But if I put a 5.5 in there, I will still have a y-intercept. It's negative 5.5. I will still have a y-intercept of positive 0.5. So it will go through there, not just half above the 0 point. And that will give me a positive root and a negative root. Have you got that? It's quite difficult, people, but I hope you are prepared to listen, to do, to listen again, to do, until you understand this. Okay. That's that one. Let's go on to the next one, people. I'm bombarding you with a lot of difficult functions. But I hope after this, you will really make a statement with what you are doing here. I wanted to show you that same sum, but it's, but because why? There's another question there. The last question, that is the last question there. Now 8a, I must go back to 8a. Almost forgot about it. You remember I left out 8a. What was the question for 8a? They said use the graph to determine the values of x where, I'm going to write it here for you, if derivative x times gx is smaller than 0. Voila! That is the question. Determine x, where the derivative of my parabola times the exponential graph will be smaller than 0. Now, people, I'm going to show you this because this is a question that you see regularly. This is just very difficult because normally the graphs are there and they ask you to find where these graphs will be smaller than 0. Now, let's see. I took the graph's equation. I found the derivative for x minus 4. Then I decided to draw this derivative because you must take this graph times gx. So I drew the straight line. X is negative 1 and y is negative 4. So there's your straight line. Okay, there's the exponential graph that was given right from the start. Now, people, if you multiply two graphs, remember this is the y value and that is the y value. Gx stands for y, fx stands for y. So when you multiply these, you must compare the y values of the graph. Compare the y values of the graph. I'm going to write it here. If it must be smaller than 0, it means that if you take your, now this is what I do in geometry also. You take your fingers, you go to the graphs. If you take the straight line there, up to there, the straight line has got a positive y value. Can you see that? Positive, positive, positive. up to there. The exponential graph, you start here, it's got a negative value. It's got a negative value, it's got a negative value, there at -1, and then all of a sudden the straight line is also negative here. So people, up to -1, a positive times a negative gives you a negative. So up to -1, from infinity to -1, you will have a positive on that graph and a negative on this graph. You understand what I'm saying if I say positive and negative? That side of that piece of the F graph is on the positive side of y. This piece of the exponential graph is on the negative side of the x-axis. So it's the x-axis as well as the negative side of the y-axis. We compare the y values. So it's negative here, positive there. A positive times a negative gives you a negative smaller than 0. So we're going to say x smaller than -1. All the way there. This one will grow, this one will there. It will never go to the positive side. So from here, smaller than -1. You will have a positive times a negative. X will be smaller than 0. And now the next, there's another piece. Let's go from this side. Here we see that both graphs are negative. So we go on. When we get there at the 0, you will see that the straight line is negative and the exponential graph is positive. So what are we going to do? Positive times negative gives us a negative. So from here onwards, both the graphs will be positive. And one will be positive and one will be negative. Can you see that? Sorry, I'm disturbing the paper in order to try to explain to you. A positive times a negative, smaller. So this question here, the product of these two graphs, the product of the y values must be smaller than 0, positive times negative. So from 0 onwards, it will also be smaller than 0, the product. So there's the two answers. Wow! Mamaiki, have you seen this in your life? Did your teacher do this with you? I hope so. Because sometimes the teacher says, he will never understand, so I'm not going to do it. But for you people, it's very important to be able to do these little difficult questions in every single question that I ask. Because you will never get a distinction if you cannot do the more difficult parts of the questions also. Have you got that? Mamiki, you use your fingers and you compare the y value. I said compare the y values, and a positive times a negative is negative. So it is smaller than 0. How must I say that? Smaller than 0. Is it right now, the 0 there? I hope so. The graphs, yes, the product, the gx times the first derivative of fx will be smaller than 0. People, will you remember it? Use your fingers, positive, negative, up to there. Negative, negative, yeah. Negative, positive from here. So it must give you a negative product. The y values must give you a negative product. Okay, I hope you understood this one. It's quite difficult. Let's go on. Now I have another question for you people. I'm just going to put this one here so that you don't see my answer before we've read the question. They've given us that gx is 3 to the power, 2 times 3 to the power x minus 1. What kind of graph is that? Yes, 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 exponential. Now, they said, determine the intercepts with the axis correct to 2 decimal digits if necessary. Now, how do you determine the intercepts with axis for all graphs? You make x0, you make y0, and then you will have the intercepts on the axis. So let's have a look. We did that one, the x-intercept. You take y0. People, all my life that I was a teacher. I was a teacher for 31 years. Then I went to the university. And while I was a teacher, I always wrote this sentence when I do intercept. X-intercept, y is 0. Don't just start the sum. I know you can do it. But you know, the more you write, the better you remember. So now we make y 0. So now we've got 2 times 3 to the x is 1. People, I don't want anything more than the base and the exponent on my one side. So that 2 must be taken away. So I divide by 2. So I've got 3 to the x is a half. Oh my goodness. People, can you see another log? Because I cannot solve these using exponential rules. So, go to logs again. This is the base. This x will be on the right-hand side, and this will be the number next to the log. And you remember that? Let's have a look. Log a half. Oh, what we did here, I took both of them to logs. You can do that, or you can rewrite it in log form from there. But this is fine. Let's put a log there. Let's put a log there. Then x is actually it is the exponent there, but it's also the number. You could take it there to the front of your log. You know, people, nowadays we don't do a lot of logs. In the old days, higher grade, we had such a lot of logs to do. Then this was very easy, actually. But now you must realize that in some sums, when you can't use exponential laws to solve something, you can take it to log form. But you must make sure that you only have one term there. Okay, this is also one term, but there mustn't be anything with your base and exponent. It must be written like that before you can go to logs. Please remember that. Okay. Now I put the x in front of that log, and to find x, I'm going to divide by that log. And there I've got the 2 logs there. And I can take out my calculator, because my calculator can work with logs. Okay, people. And my rounded answer is 0.63. They said 2 decimals. There they have it. This is our x-intercept. Now, what will be our y-intercept? We will make x 0. Wonderful. So there, this is always very easy. If you make x 0, that will become 1. And I've got 2 times 1 minus 1, which is y. So y is going to be 2 minus 1, and that will give me 1. Have you got it? Not so difficult. Not so difficult. This one was quite all right. The fact is, most of our learners will not recognize the logs there. And I want you people to make sure that you recognize the sums in which you must use logs. You take it to exponential form in its simplest way. One base with an exponent, nothing extra, a number on that side, and then you rewrite using logs. Okay, now you've seen this in your sequences and series. You are seeing this now here in your functions also. The question here, sketch the graph of G. Label clearly all the asymptotes and intercepts with the axis. People, you've got to show all of this. Now, we've already done the intercepts. There's the x-intercept and there is the y-intercept. So let's go to the graph now. If we draw this graph, we're going to say it's an exponential graph, and it's going upwards because it's got a base that is a whole number. You must remember that. Y is 3 to the power x will be an increasing graph. But the moment your base is a fraction, it will be a decreasing graph. Remember that. So you'll be able to check yourself whether you are right or not. There's the graph. The asymptote of this graph, there it is, man, kick myself. The asymptote for the y is -1. It went down by 1, but it cuts the x-axis now by 0, 1. Oh my goodness, that is quite right, people. So the asymptote, the line the graph will never touch, is going to be y is -1. I wrote it there. It's increasing because base is a whole number. X-intercept, y-intercept. And there I drew your graph for you. And have you got that one? The only difficult part here was the fact that we couldn't find the x-intercept because the exponents couldn't be used to find that. And that we had to go to logs. So that makes the question quite a difficult question. Remember this one, people? I just want to ask you quickly. If I ask you for a mirror image of a graph in the y-axis, what changes? You take this graph, you fold it on the y-axis. It means the positive x becomes a negative x. The negative x becomes a positive x. So it's going to be there. Can you see it? If you mirror image in the y-axis, x and y swaps. If you have a mirror image in the x-axis, let me repeat myself. Mirror image in the y-axis, positive x becomes negative x. Mirror image in the x-axis, positive y becomes negative y. But it will still be an exponential graph. When do I get a log graph? When do we get the inverse? Not the mirror image, the inverse of the exponential graph. Then we write it in log form. Are you with me? I hope so. Right, people, because why? The x and the y swaps places. Let's quickly go back to this little thing I did there. What will be the equation of the inverse of that graph? Y, I'm going to do it here at the bottom. Y is 3 to the power x. I want the inverse of that graph, the inverse. It will become a log graph because the x and the y will swap. So you're going to say x is, no, the x exponent comes there. This is the number next to the log. No, but I want it in the form y is. So, no. For a log form, you're going to say y is log x base 3. Have you got it? Y is log x base 3. Because we swap the x and the y. So now you say y, the exponent is always the number on the side, and the x there is always the number next to the log, and the base is the base for both of these. So firstly, what you do, you swap the x and the y, and then your equation looks like this. Then they will say you must write it in the form y is, and then you know it's going to be a log graph. This is inverse. But if I ask you for the mirror image in the x-axis, the positive x will become a negative x. So in this case, y is 3 to the power negative x. And that becomes y is 1 over, look where my x is. Y is 1 over 3 to the power positive x. I added this because it's not in one of these questions. Will you remember mirror image? It's only the signs of, in the y-axis, the x changes, and in the x-axis, the y changes, okay? But inverse means you change x and y. You swap x and y, and then you rewrite it in log form so that you have a y there. Okay, people, let's go on. I don't want to confuse you with all this knowledge. Oh, I wish we had days to do this, because then we could do all the things that's important, every little thing. But people, we don't have such a lot of time, and the June exam is around the corner, so let's do what I chose to do, and I think I really, really did at least 90% of the more difficult, let's make it 80%, of the more difficult questions that you can expect. But I could still wangle these questions, and you must be very alert to that. Let's have a look at question 6. The graphs of x is, again, ax squared plus bx plus c, and the graph of the straight line, which is a tangent, is y is mx plus k. You always remember gx is actually y. Fx is actually y. Okay. Then they said d 1 minus 8 is a common point on f and g, and this is a tangent. Then they said the graph of f has got x-intercepts there and there. They actually put it on the graph for us. Now people, when we do this, I want to look at question 1 quickly. For which value of x is fx smaller or equal to 0? Now people, that should be very easy for you. Let's have a look. There it is. I did it there because fx is our parabola. And where will the y value of the parabola be smaller than 0? For which x values? The y value is going to be negative over there. You agree? No, they said find the x values if the y value is smaller than 0. So you look at the y, and then you go, say, oh, it's between negative 3 and positive 2 on the x-axis, and that is how you write it there. It's an inequality done for you already. You must only give the solution of the inequality. There we'll have positive, here is negative, positive, positive. Have you got that? Okay, people, let's go to question 6.2. Determine the values of A, B, and C. Oh, people, it's again the same thing for this parabola, because it's a parabola that we have here. x2 is 2 because it's the x-intercept. x1, x is 1, that's your point there. Y is negative 8, and x1 is going to be negative 3. So in this case, you've got the x-intercepts plus another point. So we're going to start with that equation again. And what did I say just now? Substitute everything that you have here immediately so that you can determine the value of A. Okay, people, let's see. Instead of y, we're going to write negative 8. Instead of x1, x-intercept is negative 3, so this is positive because of the negative in the formula. x2 is 2, so this is going to be minus 2. This is x, and that is y. And there we can solve for A, and A will be equal to 2. Very, very easy if you know where to start. Where do we start if we have the turning point and another point? That is where we start. The P and the Q will be the turning points. The X and the Y will be the other point on the graph. This you only remember if you have the turning point. I'm writing it there because we don't have an example among these that will help us or give us that one to do. Okay, then for the equation, you've got your A is 2. You put your X and Y back because that is supposed to be in an equation. And then you just put the X-intercepts back again like there. Put the value of 2 in there. multiply, remove the brackets, and there you have the equation of this parabola. It's the A is 2, B is 2, and the C is 12. And they did ask for A, B, and C. They didn't ask for the equation, but people always write down the equation also, because many times they will ask you for the equation, and then you only find A, B, and C, and you forget about the equation. So when you get a question like this, you write the equation, and then you show which is A, B, and C. Right, the next question. Determine the coordinates of the turning point of F. Oh, mommy, but that's easy. There you've got the equation of F. Now, the easiest way to do this is by using the formula minus B over 2A for the axis of symmetry. Or you can also, if you want to, determine the first derivative, put it equal to 0, get the x, substitute the x into this original equation, and you will have the turning point also. But I did this one, I did both of them for you so that you can see how it's done. There you have the first method with the derivative. The derivative of this is going to be 4x plus 2. Put that equal to 0, solve for x. You cannot solve unless you have an equation. So the equal to 0 must be there. Minus 4x is 2, so x is 2 over 4, which is negative a half. Then you take this negative a half, this is the x value of the turning point. In other words, the axis of symmetry. So now you know that the axis of symmetry is x is minus a half. This is the axis of symmetry. There you have it. Now you take that x, you substitute it into the original equation to find y. Can you see that is your y? Yes. So you take a half, substitute it into that equation, and that gave me negative 12 and a half. You use your calculators for that, people. And then I can say the turning point is the axis of symmetry and the minimum value. This is a minimum. Can you see that? For minimum or maximum, first derivative equal to 0. Or you can use the formula. X is minus b over 2a. Or you can complete the square also for that equation. I would rather use the formula, because to complete the square with a number there makes it quite difficult for people who is struggling with completion of the square. So you use the formula to find the axis of symmetry, and it also gave me minus b is negative 2 over 4, and that gives me negative a half. Do the same, then substitute that into your original equation like I did there. Can you see that? There it is. And then you will get your 12 and a half, and that will be your turning point of the graph. Wonderful. Wonderful. Are you still smiling? Or are you sitting there with a long face because this is getting way too long now? I want to recommend that between each topic, you run out for 5 or 10 minutes and then come back and look at the next topic. Don't look at all of this without a break, because I even take a break between the topics. It is tiring to look at this all the time for hours and hours and hours. And I think this is going to be much more than 3 hours of viewing. So please take a break between each topic, but make sure you've got a pen and a pencil with you. You write down these things and you check it again at home, okay? Right, people, 6.4, they said, write down the equation of the axis of symmetry of H if Hx is fx minus 7 plus 2. Okay, they want an equation of a brand new graph, but they took the equation of our graph there, and what did they do to it? There's a plus 2 there, but there they actually moved the graph 7 units to which side? To the right-hand side. Because this is, if it's given like that, that is the movement on the horizontal axis. And if there's a negative, you move to the other side, to the positive side. That is the movement up or down. So please remember, if it's given in this form, This is the movement downwards in this case. Okay, so what do you do? And it's the x that changes. So what do you do now? You say, my axis of symmetry was negative a half. And now, what I do now, I add 7 because there's a negative. So the axis of symmetry changes to x is 6 and a half. So you work with the x. If they move upwards or downwards, you work with the y value. Have you got that, people? Very, very important. This is a more difficult question. It's a level 3 or 4 question, and you people must make sure that you can do these questions. Right. Then they asked another question. They said, in 6.5, they actually said, determine the gradient of G. Voila. It's lovely to see how they actually combine calculus with functions. Because if you look at G, there's your G. It's a straight line. G is a straight line. You've only got that point there. You've only got that. How on earth will you be able to find the gradient? Now, people, when I do calculus with my learners, when I do the first derivative, I always say to them, the first derivative is the formula for the gradient at any point on that graph. If I put the first derivative equal to 0, I'm determining the maximum or the minimum value, whatever they wanted me to determine there. So, what is the gradient of a parabola at a certain point? It is the first derivative. So if I get the first derivative of this equation, that is the formula for the gradient. I don't put it equal to 0. I only put it equal to 0 when I want to find a minimum or a maximum value. The y value of the turning point, for instance. Then I put it equal to 0. Right, people? So the first derivative is the gradient of the parabola at any point. I wrote it there so that you can write it down and make sure you remember it. So, this is the formula for the gradient on my parabola. But the parabola touches at 1 and negative 8. Now, I said the first derivative is the gradient of the parabola at any point. Okay? So, this is x. So you take the x value there, 1, and you put it in there. If the tangent touches where x is 1, I substitute the 1 into the formula of the gradient, and that will give me x. If x is 1, I will have 1. Where did I get that 1 from? I got it from the point that they gave us, where the tangent touches the graph. It was 1 and negative 8. That's where I got that 1 from. Can you see that? So at x is 1, the gradient will be 4 times 1, because that's the formula for the gradient, plus 2. And that gives me 6. People, so what are you going to remember from this? You cannot ignore calculus or any other topic while you are doing another topic. Because in calculus, for instance, you are going to factorize trinomials all the way. So you've got to use your equation knowledge there. Your knowledge, you must use not like a horse having these claps in front of his eyes. He cannot look left or right. In mathematics, we don't have those. We look around us. We use knowledge from grade 1 up to grade 12. We use all the knowledge that we've been taught from grade 1 up to grade 12. So never think that you won't get anything else in your functions but functions. There's a lot of things here that you've been taught in other topics that you're using here now. Have you got that one? Right, people? I hope so. Again, people, the last two questions were the difficult questions. The rest was actually very, very easy. Just remember this smaller than and larger than and whatever is given to you. Right, let's see. Let's go on to the next page. Almost through functions, people. Before you get tired, we will be done. And I hope when you go out here, you will have a hop in your step. Why? Because mathematics is your favorite. Oh, you mustn't let all the other teachers hear this, because they think their subject are the best. I think my subject is the best. Okay. And I want you to think so too, because you know what? In mathematics, attitude is very important. If you hate the subject, if you don't like your teacher, you won't get any good marks. If you love the subject, apart from the teacher, you are going to qualify for better marks. If you love the teacher and the subject, oh, people, that's a bonus. That's a bonus. And I hope you all love your mathematics teachers. They are all working very hard for you. I know that. I had grade 12s for many, many years. And I know that I sometimes didn't even sleep at night, worrying about a few of my learners that just does not cope. So please, start by loving the subject. Then start loving your teacher. Because a teacher makes a lot of difference in your attitude. Okay, I'm done with the preaching. Let's go on to the next question. There you have an log graph. Can you see it? They gave it there also. And it goes through a point. A log graph will cut at x, on the x-axis. An exponential graph will cut on the y-axis. Right. Let's have a look at this one. Prove that a is 3. So I've got to solve a. Now what I do, I take that point there. Because if I substitute a point on the graph into the equation, it should satisfy the equation. So I'm thinking that is the form of the graph given there. So I'm going to take that point and I'm going to substitute it in there. Y is -1. X is 1/3. Then, oh people, this is important. How do I write from log back to exponent? Because I cannot leave it like that, people. So, because I want a. This is what you do. The base, that's the exponent. So a to the power -1. And that number there is going to be on this side. Have you got it? So if I take that one and I want to go back to logs, what am I going to do? I'm going to say, that's your third, that is your x. Okay, the x is out now, so I cannot show you with that one now. But you must be able to take exponents to logs and logs to exponents. Very, very important. Right, so a is going to be 3. Why? Because there's a -1. So I multiply that by -1, the exponent. Then I put a -1 exponent there, and it will be 1/3 to the power -1, and that will give me a is 3 because I swapped my fraction. Okay, not difficult because that you have done quite a lot in your classes also. So that's not a level 3 or 4 question, maybe a level 2. Yeah, because of that, it can be a higher level. Write down the equation of h, the inverse of f in the form y is. Ooh. The inverse of f will be what kind of equation? The log graph, the inverse is the exponential graph. The exponential graph, the inverse is the log graph. Never, 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 never forget that. The inverse. Okay, now let's have a look. This is 5.2. The inverse of that log graph, you change the x and the y. You swap x and y because it is actually a mirror image in the y is x axis. So the first thing I do, I swap the x and the y. Can you see that? Now I've got the inverse, but it's in log form and not in standard form. Because standard form means y is. So they said, get the inverse in the form y is. So now I know that this log must become an exponent. Oh, sorry, people. Okay, sorry. I think it's the weather outside that's catching up on us. Okay, now 5.2, I want this in the form y is. And the only way to do that is by rewriting it into exponential form. That number there is the one on the left-hand side. The base stays the base. And this little one is my exponent. Go and practice that, people. Because of the fact that you didn't do a lot of logs, this is not so easy for you. But if you look at this, it's so easy if you just remember you should do this. A to the power x is equal to y. You do that from log to exponent. So this is the equation of the inverse of that graph. But what is the value of a? We've already got it. So it's a y to the power of 3 to the power of x. Y is equal to 3 to the power of x. That is your exponential graph, which is the the inverse of that graph. The inverse. It will be somewhere here on your graph. Right, let's have a look at the next question. 5.3. If gx is negative fx, determine the equation of g. Now we don't have a g graph. So this is an equation, a new equation that you will have to determine. 5.3. Gx must be equal to negative fx. Okay, what do we do there? We say this is, fx is actually, where's fx? There. Log x base 3. Okay? And what do we do with it? We put a negative in front there. So you just copy the fx and put a negative in front there. Okay, that is the equation of gx. It's negative log x base 3. Easy? Yes, not so difficult, people. 5.4. Write down the domain of g. 5.4. Write down the domain of g. Oh, I went on there. I actually thought maybe I must go on, but it is in the form y is, but people, that negative has an influence on our sum, a great influence, because I can take that negative to the top, or I can write log x over log 3, but it's a negative log x. I can put the negative there, I can also put the negative there. Now I prefer there because that will bring me to the actual equation that I want there. So this is the log of x over the log of, remember if the negative is there, you can take that negative and put it there, and that will give you 1/3. Can you see that? Okay. And then you write it like this. The bottom log is always the base. Log x base 1 over 3. So gx is equal to negative fx. Means I've got a log x with a 1/3 base. And that means it will be this log. I don't want to do too much on this graph. It will be that one. It is the inverse of this graph. No, not the inverse. It's the mirror image. What did they change? They changed the sign there. So it's a mirror image in the x-axis. This is the mirror image. I'm going to write it there. It's not the inverse because there's a log graph and this is also a log graph. But the log graph, the mirror image of log graph in x-axis. That one? Okay. That means the y changed signs. Okay. People, have you got that one? please, you mustn't stop there, because that negative shouldn't be there. And then you rewrite it like that. You can also, it's better to rewrite it like that. And then if you've got two logs like that, this actually comes from the base. So you put the base in there. That is 1 over 3. There. That negative influences it. 3 to the minus 1 gives you 1 over 3. Okay, people. I hope you've got this one. Now I've done a few on the exponential graph, but there's still more to come. 5.4. Write down the domain of G. Now there's your G. And the domain is always the x values that the graph occupies. And the graph never goes past that y-axis. So which x values does this graph occupy? It never goes, if you look at this mirror image, it will always stay on this side of my x-axis. In other words, what will the domain be? X larger than 0. Not equal to 0, because equal to 0 won't work. X an element of R, or you can say X is an element of 0 going up to infinity. You can write it in either one of these forms. Okay? That is the domain. The domain, I want to repeat it again, is the x values that the graph occupies. Is there any graph on that side? No, people. No, this is not the graph there. The graph of the mirror image there in the x-axis will go up there, but it will never touch. So it's on the positive side of the x-axis. That's why the domain x larger than 0, x an element of R, or x an element of 0 up to infinity. Then the last question, let's read that one. Determine the values of x for which fx is larger or equal to negative 3. They did not say you must use the graph. So you are not going to use the graph. The question is, determine the values of x for which fx will be larger than negative 3. Right, people? So now we say fx is actually log x base 3, larger or equal to negative 3. Now, to solve this, we've got to rewrite the log back to exponents, because we won't be able to solve it in another way. So it is going to be 3 to the power negative 3 is equal to x. You say 3 to the power negative 3 will be equal to x. You've got it? Okay, people. So then it means this 3 to the power negative 3 will become 1 over 3 cubed, and that is 1 over 20. So x larger than 1 over 27. From there onwards, your graph of f will be larger than negative 3. Remember, this is the y value. Remember that. So this is, at this x value, your graph will be larger than negative 3. Got it? Hope so. Hope so. Right, the last one on functions. Uh-oh, this is quite a sum. Let's have a look. In the diagram below, shows the hyperbola G. There's a hyperbola. I hope you recognize it without reading. With asymptotes y1 and x is negative 1. The graph of G intersects the x-axis at t and the y-axis at 0, 3. That's the 0, 3. And there's your t. And the line y is x, that line, intersects the hyperbola in the first quadrant at S. Oh, a lot of information, and you've got to use all your information. Now let's have a look. Write down the values of P and Q. Now, where's P and Q, miss? Up there, my child. There's P and q. In other words, find the equation of the hyperbola. Now let's go and look at this. We've got the asymptotes. They gave it to us there and there. That's your asymptotes. This one. It's better to make it a broken line, and there's the other asymptote, because you can confuse the axis with these lines, okay? Those are the asymptotes. They gave it to you. Now, if you go back to your equation, people, you know that you will find the x asymptote by solving this little x plus p equal to 0. So, your x asymptote, x is -1. Your y asymptote, y is 1. They actually gave it to you there also, okay? Now, you substitute the x is -1 into this equation. But now you must remember, you solve the equation. X plus p is 0, so x is -p. So that means your p is going to be +1. If you solve it, x plus 1 is equal to 0. You will have x is equal to -1. That's where I got that one from. Right, the q is always the asymptote for the y or the y asymptote. The y asymptote is y is 1. You don't change any signs there, you just fill it in there. So q will be +1 and p will be 1. +1. Because if I solve +1 there, it becomes a -1. Right, people? That's 4.2. Calculate the x coordinate of t. Now, where's t? Let's have a look. There it is. So, what does it mean to me? It is the x-intercept of the hyperbola. Can you see that? So, what do? I make my y 0. You see, I write it every single time. I saw that this is the x-intercept, so I knew y is going to be 0. Then I make y 0 in this equation. Remember, that is your y. So 0 is 2 over x plus 1 plus 1. I want to solve for x. So I'm going to multiply, I'd rather take this one to the one side and that one to the other side. You see, I swapped them. So the positive one is there, and that one went to that side. It is -1. Right. There 0 doesn't have any influence on this sum. So, x plus 1, let's put this 1 over 1. Cross multiply. X plus 1 times -1 gives me -x, -1. 2 times +1 gives me 2. You can put the negative there, you can put it there. In the end, your answer will be exactly the same. So x, I take the x to that side, I bring the 2 to this side. So positive x will be -1, -2, and that is -3. So that is the x coordinate of t. The x coordinate of t. What is the y value there? 0, people. 0, because it's on the x-axis. So t is going to be, they only wanted the x coordinate, but t is going to be -3 for the x, and 0, sorry people, for the y. That shouldn't be there. Okay. They did not ask that, they only asked this. Okay. Right. Number 3, 4.3. Write down, have you got the question there? Let's see. Write down the equation of the vertical asymptote of the graph of h. We don't have such a graph, so it's a new graph. If hx is gx plus 5. Voila! Now I wonder whether you remember what I said. If you change there, it is on the x that you are going to make the change. At the moment, your graph's equation is 2 over x plus 1. So now I'm going to substitute the x by x plus 5. So you're going to have, oh, I wrote it there. X is minus 6. Where did I get that from? Now let's see. The graph shifts 5 units to the left, because that means x is minus 5. So I'm going to rewrite this, and I'm going to say, oh, I only did that, but I want you to understand it. So let's take another piece of paper and quickly explain this to you. Write down the equation of the vertical. Let's take the equation as it is, the original equation. They are changing the x. So you're going to say hx is going to be 2 over x plus 1 plus 5. Instead of x, you have an x plus 5 plus 1. So what will the new asymptote be? X is negative 6. And I wrote everything there and I did not show you that. Let's quickly recap. That is the original equation of the hyperbola. They said h is x plus, of hx plus 5 is the new graph. So what did they do? They bothered with the x. X plus 5, but we've already got a 1 there. So this becomes x plus 6. And then if I have x plus 6 there, plus 1, my h graph will be this equation, and the asymptote for the x plus 6 is 0, x is equal to negative 6. There you have it. But people, you don't have time, because this is only going to be maybe 2 marks. Let me just quickly check. Only 1 mark. So you must be bright enough to see, I only add 5 there. And that will be x plus 6, and then the asymptote will be x is minus 6. Do you understand that, people? Okay, let's go on to the next question. 4.4. 4.4, they said, calculate the length of OS. OS, oh, this is a level 4 question again. The length of OS, there to there. Whew, people, you don't have coordinates, you do have S. You don't, yeah, you do have the coordinates. Do you have the coordinates of S? Yes, you do. Let me quickly go back to what we've done already. Calculate the x coordinate of t. No, we don't have the x coordinate of S. So we cannot use the distance formula as it is there. So what are we going to do? This is 0, 0. We'll have to find the coordinates of S so that we can use distance formula or Pythagoras. Now quickly, let's have a look at this. If I take my equation and I swap the x is y is x, why do I do that? I want I, y, s, yeah, I did it. I did it like that. Okay, I've got that equation, and in that equation I'm going to say y is equal to xy. Because if you look at this, you'll see that these two distances are exactly the same. Okay? So, Now we must try to see what we can do to find these two distances, okay? So x is 2 over x plus 1 plus 1. Now where did I get that from? The y and the x are exactly the same. So I substituted the x in there. I want to solve x and I must get rid of the y. And you know why I can do it? Because this point lies on that axis. Let me show you. S lies on that graph. Y is x. So I am fine if I take my y and I substitute it by x. That gives me an equation where I only have x's. And that's possible to solve. But in this equation, impossible, because there's a y and an x. Right, people? So I substitute that y by the x because it's on that line. Y is x. Yeah, there I wrote it. Okay, now I can solve for x. I multiply by x plus 1 right through. So I multiply x by x plus 1. I multiply this term by x plus 1. The x plus 1 will be gone. I'll have 2. Then I want to multiply the 1 by x plus 1. It's like simplifying fractions, people. You just multiply every term with the common denominator. And there is only one denominator. So we do that. Right, and then we remove our brackets. And then we get that the x's are going to cancel, because if I take that one there, it's going to become negative. There's only, I'm left with x squared is 2 plus 1. So x squared is 3, and x of s is plus or minus the square root of 3. That is x squared, and that is, and now we can say the y and the x are exactly the same. So if the x of s is the square root of 3, then the y of s will also be the square root of 3. They're both positive because they are on this side. There, let me just show you. S is on the positive side of the y-axis. So the y is positive, the x is positive. So now we have the x value and the y value of s. So we can actually say, did I write it? No, I didn't. We can actually now say s is square root 3 for x and square root 3 for y. So that coordinate there now is square root 3, square root 3. Now people, I didn't use the distance formula. I used Pythagoras. Because now if you look here, there's the origin. This is definitely going to be 90 degrees if I draw the line down there. The length of that one is square root 3, and the length of this one is square root 3. Because the x value is square root 3 there, and the y value is, oh, I'm explaining the graph without your sketch. Let's do it quickly again. We know that the coordinates of s is square root 3, square root 3. So, the x value, that's the x value, is square root 3, and this y value is also square root 3. And if you look at this, you'll see this is a perpendicular line, so that is 90. So, I've got the x value there and the y value. If that is square root 3, this one will also be square root 3. Now, people, I've scribbled too much on that sketch. Let's quickly show you now. We are going to use, for the length of OS, we're going to use Pythagoras. It's much easier than the distance formula because you've got square root there for coordinates. And the square root for coordinates makes it very difficult. So, I'm going to use Pythagoras. And I hope people, you will be awake enough to realize that there's more than one method to many things in mathematics. Now this one, the distance formula would have been much more difficult. So I'm going to say OS now. Now let's quickly draw that little triangle there. It comes from the origin, There's your S, there's your origin, a line perpendicular there, and a line there. We said this one is square root 3, and this one is square root 3. Why? Because the coordinates of S is square root 3 and square root 3. You got that? So, I want OS. So what am I going to do? I'm going to use Pythagoras, and I'm going to enjoy him a lot, because Pythagoras is easy. OS squared is the hypotenuse. Is x squared plus y squared. Square of that, the square of that, it gives me 3 plus 3, and that gives me 6. So the length of OS is square root 6. Voila, people! Can you see this is not level 1 or 2? This is more difficult. And the idea here is that you should grab this, try to remember it, and see whether you can use it in the exam also. That is going to give you a sure distinction if you can really remember all these things. Let's have a look at question 4.5. There's question 4.5. For which values of k will the equation of g, x plus k, have two real roots that are of opposite sides? Uh-oh, there I've got another one like the previous one. But in this case, gx, x plus k, what did they do? They bothered the x, not the y. So it's going to be a horizontal move, not a vertical move. So, what am I going to do? Gx is our hyperbola. And gx, you are going to put x plus k instead of x. So you're going to have, oh, I didn't even write it because I thought it's easy, but maybe it's not as easy for you. So let's have a look at this question. I'm going to rewrite it here so that you can quickly see what's going on. Gx is 2 over x plus p plus q. Now the question is gx becomes gx plus h. And this one will be our hx graph. So that can be gone now. Gx becomes gx plus h. And that will give us a new graph. So I'm going to take this x plus h and I'm going to substitute x by it. So I'm going to say hx is 2 over x plus h plus p plus q. But what is the value of p? Let's quickly see. T over, we did p and we also did q. P was 1 and q was negative 1. Now both were positive 1, sorry. So this is 2, x plus h plus p is 1 plus 1. So now, I'm writing h all the time, but they said x plus k. Sorry, k there. So, the question, for which values of k will the equation have two real roots opposite signs? So it's the x value of the graph that changes. So we're going to move this graph. We're going to move this graph negative k, negative 1, because we solved that. So x is negative k, negative 1. That's what's going to happen now to this underneath here. It's going to be x minus, and then the x is going to be minus k minus 1. And the question, for which values of k will we have two roots? Now, I said k smaller than 3. Why? Why did I say that? Let's have a look. K smaller than 3. Now, have a look at this one. If I move my my hyperbola to the right until there's still two values of x. Two values, opposite signs, real roots, opposite signs. This graph can go, 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 go. And if it comes here, it will have real roots with opposite signs because it will still be, the x will be positive if you bring the graph to be here. The x will be going to be positive there. You see, it must be above there. It is above there. And the y will be negative. So people, x smaller than 3. X smaller than 3. From here, the x is 3. Where will the x be 3? Let's take this one and solve for k. I don't know where I got that. K smaller than 3. You should get this from the graph, but it's quite difficult. K is part of my x. The asymptote will change. The graph will go down. X smaller than 3. So it's going to be the x value, 3 is going to be more or less here. If I move this graph so that it has a positive and a negative roof, it's going to be from here to that side. It's moving, no, it's moving to the right, and it's positive to the right hand side. So as it was right at the beginning, move this graph until it has two roots, which is positive and negative. It will be more or less here. We did t. What is the value of t? No, we didn't do t, so we'll have to find t first. And if that is 3, it means k must be smaller than 3. People, this is quite a difficult question. T is the intercept there on the x-axis, but didn't we do that? Let me quickly see. I'm talking myself into a confusion. Values P and Q. Coordinates of t, 4.2. I've got the coordinates. People, there it is. That's the coordinates of t. So in other words, people, k must be smaller than negative 3, not positive 3. Smaller than negative 3. That means the graph will move to that side. And you will still have a positive there and a negative there on that side. Okay, people, that's the one that I really almost confused myself. Okay? Right, people. Now, we've done with functions. Okay, people, let's have a look at 4.5. They said in 4.5, for which values of k will the equation gx is x plus k have two real roots that are of opposite signs? Can you see that this question differs from 4.3? There, the x must be substituted by x plus 5. But here, this k involves the y value. So, they said gx plus k, and then you must still have two roots, positive and negative. So, I'm going to go to my graph now. I'm trying to get everything on the screen for you. Right, it's only 1 mark, so it can't be too difficult, can it? Now, gx at the moment is this, x plus 1 and plus 1 there also, because we got 1 for p and positive 1 for q. Okay, so now, if this is the equation at the moment, you are going to add k to the equation. There, plus 1 plus k. And then we're going to look at the y-intercept there. Have you got the 3 there? K must be smaller than 3. Let's check it. If K is 2, your y-intercept will be, no, this is not the y-intercept, this is the asymptote. So if this K is 2, this asymptote will go up by 2. Can you see that? So it will be there. All the graphs will go up to there. If you move the graphs up, you will see that you have 2 roots. One positive, one negative. So, K cannot go past that 3 there. So K can only be smaller than 3. That mustn't be more than 3. It can rather be smaller than 3, so that the asymptote doesn't go beyond that 3 there. Have you got that? It's quite a difficult thing to explain, but it's only 1 mark. So remember, just if they give it to you like that, the K involves the asymptote. So your asymptote cannot go past that 3. So K must be smaller than 3. Because if K is 3, it's 4 there. Wrong. If K is 2, you've got 3. Fine. If K is 1, you've got 2. So you cannot move beyond that 3. So K is smaller than 3. 1 mark only. Thank you, people. That concludes our functions. I hope you learned something from here and that you will be able to apply it. Good luck with your functions. It's not the easiest topic. Thank you.